So we've discussed that cells are very tiny. And so in order to discuss cells, you kind of need some kind of an understanding of how small a micrometer is, or a millimeter, or a nanometer, or a picometer, and particularly these three, micro, nano, pico, because you don't really use them. Like in chemistry, a lot of stuff is going to be in milligrams, or kilometers, or whatever. And so micro, nano, pico are these little teeny tiny. The micro is this Greek letter called mu. It looks almost like a U, but it isn't, a Greek M for micro. And these are really small, 10 to the negative 6. So a micrometer is 1, 2, 3, 4, 5, this much of a meter. So here's the thing. They could ask you to do some kind of metric conversions on the AP exam. And so I wanted to show you a couple of ways you can do this. I'm going to show you dimensional analysis first because that's the method you would normally use in chemistry. However, a lot of times with dimensional analysis, it's more convenient because they actually give you a direct conversion between the units. We don't really have that here. If we look here, I know that 10 to the 6th meters is equal to 1 megameter. That's what this basically means, is each of these factors are how much of a meter each of these prefixes represents. So 1 megameter is very big. It's 10 to the 6th meters, whereas a picometer is very tiny. It's only 10 to the 12th of a meter. So if you had 1 picometer, you would have 10 to the negative 12th of a meter. 6, 7, 8, 9, 10, 11. This tiny amount of a meter. But what if they asked you to convert from picometers to micrometers? I don't necessarily, from this chart, have a conversion factor that just says how many picometers is a micrometer, or how many micrometers is a picometer. And so if you were going to solve this using dimensional analysis, you really don't have a direct conversion. But I will show you that you could still do it, but you'd have to convert to meters first. So let me show you dimensional analysis first. So if we were going to use dimensional analysis to convert 2.5 times 10 to the 4th centimeters to picometers, what we would have to do is find Cinti, find Pico, and we don't have a direct relationship, but what we do know is 10 to the negative 2 meters is 1 centimeter, and 10 to the negative 12th meters is equal to 1 picometer. So, if I was going to do this using dimensional analysis, which I don't think is the recommended way to do it because you're going to be in a hurry on the AP exam, so doing this method is going to take a little more time, but you can do it. You would have to do this. So 2.5 times 10 to the 4th centimeters times, so my first conversion factor, I need to get rid of centimeters. So I know I need centimeters on the bottom, and ideally it would be great if we could put picometers on the top, but we don't have a direct correlation. So we could have to convert from centimeters to meters, and that way our centimeters would cancel. So to go from centimeters to meters, I know that 1 centimeter is 10 to the negative 2, or 1 times 10 to the negative 2 meters. And I'm writing this as 1 times 10 to the negative 2 because some of your calculators, if you just put in this times 10 to the negative 2, it's going to give you a syntax error. So if you put it in as 1 times 10 to the negative 2, that should solve the problem. Now I have meters, but my question was converting to picometers. So now I have a second conversion factor. I'm going to convert from meters to picometers. So now meters is going to cancel, and my answer will be in picometers. So what's my relationship? That 1 times 10 to the negative 12 meters is equal to 1 picometer. Now meters will cancel. Now to solve this in your calculator, you would literally do this. 2.5. Now, if you know how to use your calculator, probably has an EXP button, or if you have a graphing calculator, it's second function double E, or maybe you have something that says 10 to the X. So if you have one of those buttons, the shortest way to do this is to do 2.5, hit that magic button, 4. That basically means times 10 to the, and then you just put in the exponent, times 1, hit that E button, negative 2, that's the negative sign, not minus, and then divided by, because this is on the bottom, 1e negative 12. And that should give you the right answer. If you don't know what I'm talking about with this E button, if you don't ever remember using that in chemistry, Then the other way you can do this in your calculator would be 2.5 times 10, you'll hit this little caret button, 4, then times 1 times 10 caret negative 2. And then for this last step, you're going to have to use parentheses or your calculator is going to do this weird order of operations. So you'd have to do parentheses 1 times 10 to the negative 12. So these would be two ways you could plug this into your calculator. Bottom line, the answer that you're going to get is going to be, if you did it correctly, 2.5 times 10 to the 14th picometers. Now, you can see this is lengthy, and it requires you to figure out how to read this and turn it into these conversion factors. But there's an easier, faster way to do this, and this is a modified lecture. I was teaching this in a lengthier way, but this is actually even better. A couple students suggested this, and I thank them for that. All you're going to do is you're going to use this table directly. Now, one thing that's missing from this table, and this is important, they don't actually have the base unit. In other words, remember, with every measurement, like if I have something in picometers, my first letter is my prefix. My second letter is my base unit. In this case, we've been talking about meters because we're talking about cell sizes. But we could also be measuring something that we're weighing, in which case we could have that second letter be grams or liters. The reason I mention that is, what if the conversion that you're doing is 27,000, let's say, picometers, and they want to know how many meters that is. So people look at this problem, and they see the M by itself, and they go, M, oh, that's milli. That is not milli. Remember that you are always going to have two letters if there's a metric prefix. If you only see one letter here, that's not milli. That's just meter by itself. So I would be converting to meters. So where is meter in this chart? Because they didn't put it here. Well, meter or gram or liter, your base unit, we'll just call it base. So this could be meter, gram, or liter. That would be 10 to the 0. So just a heads up, that's where that would fall in this chart. All right, so watch how easy this method is going to be. So I'm converting from centi to pico. So I'm going to find centi. I'm going to find pico. And I'm literally going to subtract the exponents. So centi first, because that was the first one. So minus 2 minus pico, the exponent is negative 12. So negative 2 minus negative 12. All right, so if you work that out, your answer is going to be 10. Guess what? That means that's how many decimal places I need to move. If I get a positive answer, like I did here, positive 10, I'm going to move my decimal to the right, 10 places. Or if I have a number like this one, the 2.5 times 10 to the 4th, 10 just means I'm literally going to add 10 to my exponent. And I get the same exact answer, 2.5 times 10 to the 14th. So I'll repeat that one more time, and then I'll show you 3 quick sample problems. So I'm going to subtract my exponents from the chart directly. First, the one I'm converting from minus the one I'm converting to. So I had negative 2 minus negative 12. That gives me an answer of positive 10. That means I'm going to add 10, positive 10, to my exponent. If my answer was negative, I'd add negative whatever to my exponent. Now, what if there isn't an exponent? Then you may have to physically just move your decimal. If you get a positive number, you're going to move it to the right. If you get a negative number, you're going to move it to the left. So let's do these 3 practice problems. Number 1, 250 millimeters to nanometers. That is an error. That should be a lowercase n. It got changed somehow. I apologize for that. So we find milli. We find nano. Negative 3 minus negative 9. My answer to that is 6. So what does that mean? That means if I had an exponent, I would add 6 to it, but I don't. I'm just going to move my decimal, since this is a positive number, 6 places to the right. So 250, the decimal is here in the number 250. 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6. This is my answer. Now, I would prefer you put an answer like that, as the College Board would too, into scientific notation. So this would be 2.5 times 10, and then your exponent here, if you don't remember your scientific notation, should be how many places you would need to move your decimal to go back to your original number. So in 2.5, I would have to move it to get to this number, 1, 2, 3, 4, 5, 6, 7, 8 spaces. So it's going to be 2.5 times 10 to the 8th nanometers. Let's look at our second one. So this time we're going from micro. This is just meter by itself. So remember what I told you. Where does meter fall in this table? Meter, I'm going to use a different color here. Meter would be a base unit. It would be here, right where it swaps from being negative to positive. That's 10 to the 0. That's just meter or gram or liter with no prefix. So micro is 10 to the negative 6. So my first number is negative 6. I'm just using my prefixes here. Oh, I'm sorry, milli. Oh, no, it is micro. I apologize. Yes, micro. 10, so negative 6. And then my second, I'm going to meter, which is 0. So negative 6 minus 0 is negative 6. What does that mean? That means I need to move my decimal to the left 6 places. Negative means left. So my current decimal is here. I would have to add 1, 2, 3, 4, 5, 6 zeros. So my new answer is going to be 0.1, 2, 3, 4, 5, 6, 7, 5, 5. Now again, I would recommend you put a number like this in scientific notation. So that's going to be 5.5 times 10. My exponent is how many places I would need to move this to go back to my original number. So from 5.5 to take this to my original number, 1, 2, 3, 4, 5, 6, 7, negative 8. That tells me my original number is smaller than this. It's actually 8 decimal places to the left of this. All right, let's look at our last one. Giga to centi. Let me change colors again to green. All right, so find giga, 9. Find centi, negative 2. 9 minus negative 2 is 11. Since this one has an exponent, I'm literally going to add my answer here, positive 11, to my exponent. So negative 7 plus positive 11 is going to give me 1 times 10 to the positive 4. And that's my answer. So I think this is a much shorter and easier way to do these than to use dimensional analysis, although you're welcome to use dimensional analysis if you want to. But I think this is really easy. So you find your first prefix, find your second one, subtract your exponents. Remember that if you get a positive answer, you're going to move your decimal to the right. Or if your original number has an exponent, you're literally going to add that answer to your exponent. If you get a negative answer, like you did in this one, we're going to move our decimal to the left. Or if you had an exponent, you would be adding your negative number to that exponent. And that's it.